Hi class, I'd like to welcome you to a whole new chapter actually. We are on chapter 6 now, which is all on quadratic functions. So what we've talked about so far in this class has been linear functions. So y equals mx plus b. Linear functions are where our y variable and our x variable are both raised to the power of 1. So that's why they're not written in there, because you always assume it's a 1. With quadratics, our x variable is raised to a power of 2. So it's more like y equals ax squared plus bx plus c. That's standard form for our quadratics. But as you can see, our degree, or our highest power of x, is the number 2. It is x squared. So that's what this chapter is going to be on. This video lesson is just going to be on the terminology that we're going to be using for this whole chapter, so please pay very close attention on this video. I want to make sure that we're all speaking the same language, so that when I say axis of symmetry, you know exactly what that means. Or when I say vertex, you know what that means, so on and so forth. So let's just talk about this terminology so that we're all on the same page. This quadratic function, y or f of x, for standard form is ax squared plus bx plus c. If you want to think of this as an example without so many letters, you might see something like y equals 3x squared plus 7x minus 3. Okay, our a would be the number 3, our b would be the number 7, and our c would be the negative 3. Okay, so the a is always the number in front of the x squared, the b is the number in front of x, and our c is that constant term. And they always go in descending order. X must be in descending order. So that means you start at the x squareds, and then you go on to the x to the first power, or just the x's, and then you end with the constant. That's what descending order means. You start at the top and work your way down. Quadratic functions always have a value for a that is not 0. That's where it says a cannot equal 0. If a was the number 0, you would have 0x squared, which if you didn't have an x squared term, you just had this bx plus c. Well, now you're down to a linear function. And we're not talking about linear functions, we are talking about quadratics. So every time in this chapter, a will be a value other than 0. All right, our a value tells us some very, very important things. Moving on to graphing a parabola, this will be the second underlined point under your notes. Graphing a parabola, if a is a number that is greater than 0, the parabola opens up and has a minimum value. So if my equation, let's just say for example, was y equals x squared minus 2x plus 4. We'll just say it's something like that. I don't know how this would look. I'd have to put it into a graphing calculator. But just for example, we know that my a value is a positive 1. It's the number in front of x squared. So this would open up. Parabolas are U-shaped. So this U shape would open up. My two arrows are going upward. And it has a minimum value. That means that I have a point that is at its absolute lowest. Minimum means low, a lowest point. It doesn't have a maximum point because these go up and up and up and up and up and up forever and ever and ever and ever. So there is no maximum value. Sorry about that. There is a minimum value though. That is only, however, when a is positive. If you were to see something where a is negative, something like y equals a negative 2x squared plus 17x minus 13. Once again, I don't know how this would look. I'd have to put it into my graphing calculator. But I know that if the value is negative, it's going to open down. So it might look something like this. It opens down so that U is kind of turned upside down. It's an upside down U shape. And it would have, going down here, if A is less than 0, so meaning negative, then it opens down and has a maximum value. So there is an absolute highest point in this graph. It is right there. Okay? It doesn't have a minimum point because these arrows go down forever and ever and ever and ever. So because of that, it does have a maximum point. That arrow was really bad. All right. So that covers that. Moving downward, we have what is called an axis of symmetry. In parabolas, the definition, the axis of symmetry is a vertical line that cuts the parabola in half. What you guys learned in geometry is that symmetry is basically that mirror thing that you guys talked about in geometry, how if you fold something along a line, this line of symmetry has identical features on this side of the line as well as this side. So because that is the case in parabolas, parabolas are always symmetrical. So they have a line of symmetry. If I were to draw a parabola like this, I could draw a vertical line right down the middle, and if I were to fold this piece of paper basically on that red line, the two green lines right here and right here would fold right on top of each other. That's that line of symmetry. That's that axis of symmetry. It's a vertical line, so it goes straight up and down, and it cuts the parabola exactly in half. You find this by saying it's a negative b over 2a. We're going to have some more experience with that as we get on to our example problems, but to find the axis of symmetry, it's an x equals line, so that's why you see x equals. X equals is a vertical line, and you find that vertical line by putting in a negative b over 2a. So just for example, if it was y equals 3x squared plus 5x minus 12, a negative b, our b value is 5, so a negative 5 divided by 2a, so 3 times 2. 2 from here, 3 is our a value. So a negative 5/6 would be our axis of symmetry. So on a graph, here's a negative 1, a negative 5/6 would be about right here. And so you know you'd have this vertical line that your parabola would be symmetrical about. So it might look something like, just as a guess, something like that. All right. To find the vertex, what you do is you substitute in a value from, you substitute in the value of the axis of symmetry for the x coordinate to find the y coordinate. So let's talk about what a vertex is. Going back to geometry, when you guys did angles, the vertex of an angle is the point where the two rays meet. So here's a ray, they meet at this point right here. That intersection point is called a vertex. So going on with that same thing, our parabolas are U-shaped, so they don't look like an angle. That's a bad U. So they're U-shaped, so they don't have that sharp point of an angle, but the vertex is still at that absolute lowest point, or that minimum, or the highest point being a maximum. So go to the point where there's a change of direction, and that's where your vertex is going to be. Your vertex is always going to be at the axis of symmetry for the x value, and the y value you find, just like it says up there, you find by substituting in that x value. So we're going to have more practice with that when we get to our problems as well. But our axis of symmetry is always an x equals line, and our vertex is always an xy ordered pair. The x coordinate is the axis of symmetry. The y coordinate, you're going to find that by substituting in the axis of symmetry for x and getting a resulting y value. So that's how you find the vertex. All right, last thing, to graph it. Once you find the axis of symmetry, which is oftentimes written in a dotted line, and once you find a vertex, which is somewhere on that line, then you have to know how that U shape goes. If it goes like this and like this, whatever the case might be, you have to find how that U shape works. One thing you could do is you could just use your graphing calculator. And then with your graphing calculator, you're going to go to your table, which is that second graph button, and then you could find XY ordered pairs and you could plot them. That's a perfectly fine way of doing it. Another way you could do it is you can make a table, and you guys probably did this with linear functions back in like the 7th or 8th grade or something like that, where you could say, well, let's see what happens when x is 2, what happens when x is 1, what happens when x is 0, -1, -2, and then you get these resulting y values. You can plot all those on your xy coordinate grid, and you can get a picture. That one is more tedious. I wouldn't recommend doing this one, but you certainly could. The one that I think is the easiest after extensive work with this is this third one, is memorize patterns for a. When your a value is 1, so when the number in front of x squared is 1, let's say when it's y equals 2x squared minus, I said when x was going to be 1, or a value is going to be 1. When y equals x squared minus 2x plus 3. If this is the case, your a value is 1. When a is 1, here's your pattern. You're going to go up 1, right 1, up 3, right 1. So you're going to go from your vertex, up 1, right 1, you're going to have a point, and then you're going to go up 3, right 1. And here is the right side of your parabola. That always works when your a value is 1. Now remember, parabolas are always symmetrical, so what you do on the right side, you also do on the left side. You go up 1, left 1, you have a point. From this point, you go up 3, left 1. And there's your point. And there is your symmetrical graph. If your a value was 2, you go up 2, right 1, up 6, right 1. So if my a value was 2, let's say this was 2x squared, so on and so forth. From your vertex, you go up 2, right 1, up 6, right 1. And there would be your graph. Likewise, if you do the same thing on the left side, because they are symmetrical. And then I think you're maybe getting the pattern. If it was an a value of 3, you would go up 3, right 1, up 9, right 1. So every time, you're basically multiplying by 3 to get from one to the next. 2 times 3 is 6. 3 times 3 is 9. So if your a value is 4, you would go up 4, right 1, up 12, right 1. Because 4 times 3 is 12. So that pattern keeps on continuing. So as you can see, the higher and higher your a value is, the skinnier and skinnier your graph is going to be. What happens if it was an a value of 3? If your vertex was right here on an xy coordinate grid, you would have to go up 3, right 1, up 9, right 1. This is a very, very skinny parabola, isn't it? As compared to this one, this green one, which is much wider. So as you can see, the higher your a value is, the skinnier your graph is going to be. So that's just getting a little bit familiar with the terminology that we're going to be having in this chapter.